All right, so in this video, we're going to be talking about dimensional analysis. It's a really important chapter or section of a chapter that we're going to go through because it's something we're going to use not only in this class, but you might also use in other classes, like nursing classes. So it's definitely an important chapter and something that we should be familiar with. And once I get control of my screen, there we go. Our goal for this chapter is for a problem to identify wanted and given quantities that are related by this mysterious thing known as a per expression. And then we want to be able to set up and solve the problem using dimensional analysis. So what is dimensional analysis? Well, it's a problem-solving method featuring algebraic cancellation of units and the use of a per expression. And what a per expression is a conversion factor or a mathematical statement expressing the relationship between two quantities that are directly proportional to each other. So if I can give you a simple example like the one shown here, we know that there's, for every 1 week, 7 days. Okay? And the opposite is also true. For every 7 days, that's 1 week. All right, so these are, again, a relationship between two quantities that are directly proportional to each other. And we use these types of conversions all the time. If you go to the grocery store and bananas are 25 cents per pound, we're converting, or there's a relationship between the amount of bananas you buy in that case and the price you're going to pay. It's the same idea. So these expressions, or the per expression, can be written out in a form like this. All right, so each expression yields two conversion factors that are expressed as fractions. All right, so this can be written as, I'll write it over here. So 1 week over 7 days, and then that equals 7 days, 1 week. They're equivalent. Okay, so these, again, these two expressions yield conversion factors expressed as fractions that are reciprocals of each other. All right, and using this per expression, then we can convert between one unit and another. So if I asked you, right, how many days are in 3 weeks, you'd probably do that in your head and calculate it very quickly. And in doing so, you've just done dimensional analysis. You use the conversion factor in your mind to arrive at that answer. But we want to look at it algebraically. We want to be able to write out the expressions and explain step for step how we're doing problems like that, because the problems we're going to see later on in the semester and even in this chapter are going to be a little more complicated than that. So we want to have a better idea of what we're doing, so we'll be able to solve any type of problem using dimensional analysis, or any type of problem that requires dimensional analysis, I should say. So let's go through a quick example, and in the next video, we're going to do several other examples. So here's how we're going to solve problems using dimensional analysis over on the left. And on the right, I'm going to be going through the problem with you. So the question is, how many days are in 23 weeks? All right, so we're going to follow these steps again that are on the left, and we're going to write everything on the right. So the first step here says to identify and write down the given quantity, including units. All right, so for given quantity, we're starting with 23 weeks. Okay, so step 1 is done. Step 2 is identify and write down the units of the wanted quantity. All right, so this is step 1. Step 2, well, the units of the wanted quantity is days. Excuse me, I have to move something on my screen. You may not be able to see it, but it's blocking me from writing here. So give me a sec. Okay, that's better. All right, so that's step 2. So now that we've done that, so we've written down what's given, we've written down what's wanted, now we now we want to write down the per expression. And again, I know that there are 7 days per 1 week. All right. And the path we're going to take, I want to convert 23 weeks to days. Okay. So now that's step 3. All right. All of this is step 3. So step 4 now, I want to write down the calculation step, including units. So 23 weeks times, for every 1 week, this is my per expression, there's 7 days, and we're going to get an answer. So notice here that the units of weeks cancel each other, okay? So we have weeks here and weeks here. They cancel algebraically. And what we're left with is the unit of days, okay? So we know that we did the problem right, and I'll give you an example of how you might do the problem wrong in a second. All right, so now we're going to calculate the answer here. And I believe, let's see here. Do I have the answer written down? That would be helpful if I did. So I might have forgotten the answer. I think it's 161 days. Okay, so let's just double check that. So 161 days. Yep, that's correct. So that's the number of days in 23 weeks. All right, so we calculated the answer. Now we're going to do step 6. We're going to check the answer to make sure it makes sense. So what do I mean by that? Let's say I wrote it this way. So this would be the wrong way. All right, so don't do it this way. What if I did this? 23 weeks times, for every 1 week, 7 days equals. All right, so that's going to give me some weird number that you don't have to worry about calculating. But look at the units. Nothing cancels out, and my units are week squared days, right? It wouldn't take us long to recognize, or it shouldn't, that something is wrong here. What is a week squared day, right? Nobody knows. Some made-up unit that we've just come up with in our class, right? So this is wrong. This is if we did something backwards, right? So the units need to be treated the same way as we would treat variables, right, in algebra. So specifically, they need to cancel. If they don't cancel, then we get an answer like this, okay, a week squared day. And this is one of the valuable features of doing dimensional analysis, is that if you get an answer that's complete nonsense as far as units go, you know that you made a mistake. And that's why it's critical that here in step 2, we always write down the units of what we want, right? We wanted days here. So when we end up with a week squared day, it doesn't make any sense. All right, so that's an example of dimensional analysis. In the next video, we're going to do several more examples, going through some practice problems together.